Welcome to Brain Vision.
Hi. So we're given a question that this bent bar, has an angular acceleration of 5 rats per second, angular velocity of 2 rats per second, and we want to find the velocity and acceleration at point A. So first of all, with velocity, the formula we're going to use is v is equal to r omega. And r is the radius, omega is the angular velocity. That would be equal to. So we need to break this into components. At this point, the velocity will be directed towards this direction because the angular velocity is going counterclockwise. And this horizontal side of the triangle is going to be 0.5 cos 15, and this is going to be 0.5 sine 15. So we can break this velocity vector into two components, into the vertical and the horizontal. So it's going to be up and right. And let's take the horizontal component first. The radius is going to be this vertical line. So it's going to have 0.5 cos 15 times the angular velocity, which is 2. And this is in the positive I direction, positive x direction, so positive I plus. This is in positive j direction also, positive y. So this is going to be 0.5 sine 15 times 2 g. And then next, we need to come to this side, the second triangle. I'm draw it out here. And the velocity be directed this way into components. It's going to be up and right. And to find this angle, we can draw this like this, and this part is 15 degrees because this part is 15 degrees by alternate angles. So 15 plus 90 plus, let's call this place x, plus x equal to 120. So x will be equal to 15 degrees, which means that this part is also 15 degrees. So 15 degrees. So this place will be 0.5 sine 15, sorry, 0.3 rather. So we're also going to add this, and if we take the horizontal first, we're just going to be this side. We're going to have plus 0.3 sine 15 times 2 I plus, and then the vertical, this will be the radius, 0.3 cos 15 times 2 g, and our result is going to be 1.121 I plus 0.838 g. And this is in meters per second. Next, we'll do the acceleration, tangential acceleration. First of all, optimal acceleration. So for tangential acceleration, we come to the same triangle again. And the acceleration will be directed down in this direction. And so the formula for that is going to be r alpha times angular acceleration, and components down on left. So we're going to have minus 0. We're taking the horizontal first. Horizontal component, this will be the radius. This vertical line, 0.5 cos 15 times 5 I minus, then for the vertical, 0.5 sine 15 times 5 g, and for this side also the acceleration will be in this direction, so we're going down on left, and this is going to minus 0.3 cos 15 times 5 g minus 0.3 sine 15 times 5 I. Alright, so we can see that it's basically the same thing as the velocity, just with this value changed, and the signs changed also because it's in opposite directions. The velocity was in this direction, acceleration is this direction. Alright, so now for the normal acceleration, the formula we're going to use is r omega squared, and we can load these up. And the normal acceleration is directed towards the center of rotation. So the components will be up and left. So if we draw a triangle again, this side is cos, this side is sine, because the angle is here. So 0.5 sine 15. So we have the radius. Let's take the horizontal first. So this will be our radius for the horizontal, and it's going to be plus, and that's going to be negative actually, because it's the negative x minus 0.5 sine 15 times 2 squared I, and this for the vertical is in the positive y direction, so plus j plus 0.5 cos 15 times 2 squared j, and then for the other side 15 is 0.3 cos 15, 0.5 cos 15. So we're going to add the ones for these also. So plus, we're taking the horizontal first. Okay, so let me draw the vector for that part. The normal is going to be direction of the acceleration to be here, or normal acceleration, and that'll be up and left. And taking the horizontal first, this will be the radius minus, that's the negative x direction, minus 0.3 cos 15 times 2 squared plus This one is in the positive y direction. 0.3 cos 15 times, it should be sin 15 times 2 squared j. Alright, so for the total acceleration, we add the tangential and normal accelerations, and the answer is going to be minus 4.48 I plus 0.146 g meters per second squared. That's our final answer.